Welcome fellow learners. In this video, we will take a deep dive into how states in LangGraph work, and we'll also explore different types of state schema. The state in LangGraph defines how information flows through the graph. It contains the schema of your graph and the reducer functions that apply updates to these states. So let's look at the diagram. This shows how this information flows through the graph. So usually every LangGraph begins with one foundational step defining the state. Now these states consist of schema and reducer functions. Now these schema defines input to the all nodes and edges of the graph. And after some modification, these nodes will emit updates to these state and reducer functions will help them to apply to these states. So now let's explore the LangGraph state in depth with the help of the code. So state schemas can be defined by either TypedDict or by Pydantic. So let's first look at how we can define state schemas with the help of TypedDict. So TypedDict is a special feature provided by typing module from Python, which lets us to create a dictionary with fixed structure and where we can define a fixed set of keys and having particular type of values. So over here, let's first import TypedDict. And now to define a state schema with the help of TypedDict, we can directly create a class which should inherit TypedDict. And over here you can see I have created this class TypedDict and provided it with two keys. The first one is name and second one is age. And I have also defined the type of the values which it should contain. So let's run this cell and it will create this TypedDict state. Now to initialize this TypedDict state, we can directly pass a name and age to it. So I have passed a name Rahul and age as 30 over here. And over here you can see it has created that state. Now as we have defined age as int and over here you can see I have passed 30 years which is a string to age. You can see type checker is giving us error that this 30-year literal which is a string cannot be assigned to a parameter age of type int. So in this way we can clearly see that with the help of this TypedDict module, we can see type checker provides us any type of misconfiguration that we have provided as an input to this our state schema. So let's run this cell. But now you can see the problem is like even we have defined or we have provided a string instead of int to this age. It was able to create this TypedDict state. The problem is the TypedDict doesn't check at runtime what kind of type of values we are passing to it or what kind of keys that we are passing to it. So let's say I pass any other key to it, let's say years or something. It will also do not give us any error over here. So how to solve this problem? So to solve this problem, let's look at how we can utilize Pydantic model to define a state schema in the graph. So Pydantic is a separate Python library which can be used for data validation. It supports automatic type checking and type conversion wherever it is feasible. It also supports default values, optional fields and validators. So let's first import base model from Pydantic. This will be used when we are going to define the Pydantic state. So over here you can see I have defined a Pydantic state class and inherited this base model. I have also defined name and age, same two keys which I have defined for TypedDict state. So let's run this cell and it will define our Pydantic state. Now for example, let's pass name as Rahul and age as 30 and let's run this cell and we can see that this Pydantic state has been created. Now over here you can see that I have passed 30 as a string to this age and we have defined int to this and you can see for the type checker it is giving us a warning that it cannot be assigned to a parameter age as it is an int. So let's run this cell and let's see what happens. So over here you can see it has automatically converted the type of that string into int as this Pydantic has the capability to automatic type checking and type conversion wherever it is feasible. Now let's have a same example which we have provided for the TypedDict and we have given it as 30 years as a string to this age. Now from the type checker, it is giving us a warning that it cannot be assigned to parameter, as parameters can only be of type int. But let's run this cell and let's see what happens. We can see that now this Pydantic model is giving us a validation error that input should be a integer, and it is unable to parse string as an integer. In case of 30, it was able to parse that string into integer, but in case of 30 years, it is not able to parse, and that's why it is giving us error. While in case of TypedDict, it was giving us a type checker warning, but at runtime it was not giving us any error, and actually it was creating a TypedDict state. So in this way, Pydantic can be more helpful than that TypedDict state. So let's take another example by passing age as a value of -1. As you know, age cannot be -1, it cannot be negative. So let's run this example firstly by using TypedDict, and we are using typed state class over here. So let's run this cell, and as it was expected that this TypedDict doesn't throw any error at validation time, so we can see that it has provided and created that TypedDict state. Now let's run this example by using Pydantic also. So let's copy this and paste it over here and use that Pydantic state class, and let's run this cell and let's see what will happen. So now we can see that Pydantic has also created this state without giving any error, because we have not given any condition anywhere that age cannot be negative, and we have only provided that age can only be int type, as -1 is an int type. That's why it has not provided any error. So now what we can do? So in Pydantic we have a feature, and it has a capability of creating validators for each of those keys which we have defined in the Pydantic state class. So what we can do, we can first import this field validator from Pydantic, and while we are defining that Pydantic state with the help of base model from Pydantic, what we can do, we can create a function which will have some particular condition on that age key. So over here you can see I have passed this age to this field validator, and then defined a validate age function where I have given a condition that value cannot be less than 0, and if the value is less than 0, it will raise a value error. So let's run this cell, and it will define our Pydantic state class which is already having this field validator applied to age key. Now let's run the same example again. Now over here you can see it has given us validation error, and it has given the error that there is a value error and age must be a positive integer. So in this way we can see that Pydantic can be really helpful when we are creating our graph in the LangGraph. So now let's see how these states are used in LangGraph. So let's first import a few things which are required to create the graph. So like state graph, which will initialize our graph, start and end. These are two predefined nodes in the LangGraph. So let's run this cell, and it will import these modules. So this display and images will be used for displaying the graph. Now let's create a node. This node doesn't do much. It only increase the age by 1. And you can see over here in this typing I have provided, like the input will be a Pydantic state which we have defined earlier, and output will be a Pydantic state. So if you see, and if you remember, earlier we have created this Pydantic state class, and this is the state which is going to be passed through every node and edge of our graph. So let's run this cell, and it will create our node. So let's create a simple graph. So over here you can see I have initialized the graph with the help of state graph, and passed that Pydantic state as a state to this state graph. Then created a node, this node A, and named it as A. Then created an edge between start and node A, and then created a final edge between node A and end. So then after that I have compiled this graph, and it will create our graph. So let's run this cell, and we can see it has created this graph. There is start node, there is a node, and there is a end node. Now let's invoke this graph by passing input to this as name as Rahul and age as 30. So let's run this cell, and you can see with the help of this node which is increasing this age, this output has increased the age by 1, and it has given age as 31. Now to check if our Pydantic class and that Pydantic state is working or not, so let's provide it with a different example. Let's provide it as age as a -1 or -2 something. Let's run this cell and you can see that it has given us error, and we can see that Pydantic state is working fine. So now let's jump into the next section where we explain about multiple schemas. Usually all graph nodes shares a single schema in which they read and write to the same state. Like each node will read and write to the same state. But sometimes we might need more control in our graph. So let's say for an example, there might be the cases where from one node to another node, we might need to pass few informations which are not needed in input and output schemas or input and output states. There can be another example where we might need to define a different input and output schema from the overall state. So like in output state, in sometimes we might only need to have a single key which should be shown to the user, and in our overall state there can be multiple keys. So these are a few examples where we need multiple schemas rather than a single schema. So let's see how we can implement first example which I have provided over here, that internal node can pass info that are not required in the graph's input and output. In this case, instead of just creating an overall state, we can have a private state which can be passed from one node to another node. Let's see how we can implement this. So over here you can see I have created two states. The first one is overall state, which is having two keys, name and age. The second is private state, which is having a key, a separate key, a salary. Let's run this cell and it will create these two states. Now over here you can see I have created two nodes. The node A takes overall state as an input and returns a private state, and node B takes private state as an input and returns overall state. So what you can see over here is, like, node A is passing a private information from to the node B. So there is a communication between node A to node B which is different from the overall state information. So let's run this cell and it will define our node A and node B. And in the graph you can see I have created these two nodes, node A and node B. There are three edges. One is from start to A to B, and from B to A. So let's run this cell and it will create our graph. So you can see over here there is start, then to node A, then node B, and then end. Let's run an example. Let's invoke this graph and let's see how does it work. So now you can see in this output, like node A, which is having input of overall state, is having input name and age. So this overall state is consist of both name and age. And in node B, which is having a private state, you can see over here it is having only salary as an key. And in the output you can see we have name and age, which is from the overall state. So in this way you can see that this private state passes from node A to node B irrespective of whatever was provided in the overall state. So now let's look into another example where we define separate input and output schema. So over here you can see I have defined three states. The first one is overall state, which is having all the key required in the graph, name, age and info. The second state is input state, which is having only a single key, that is age. And there is a third state which is an output state, which is also having a single key, info. So let's run this cell and it will create these states. Now over here you can see I have created same two nodes, node A and node B, but there are few differences. So like node A, instead of having overall state as an input, it is only taking input state. So which will constrain this graph to having a specific input and output. So like in node A, it is constrained to having only input state, and node B, it is constrained to provide only output state as an output. So in this node A, input state will be given as input, and over here you can see I have returned this name, age from this node A, and in the node B it is having input as overall state, and in return it is only returning a single key, info, as an output, which is correct as we have defined output state to contain only info as a single key. So let's run this cell and this is the same graph that we have defined earlier. The only difference is in initializing the graph, the state graph, when we are initializing this, we are passing input schema as an input state and output schema as an output state. So in state graph, in LangGraph, they have already provided that we can define input and output schema. So over here you can see input schema, the schema class that defines the input to the graph, and output schema, the schema class that defines the output from the graph. So let's run this cell, and you can see this is the same graph that we have created earlier. The only difference is like input schema and output schema. So start, node A, node B, and end. So let's run this cell. Now one thing that you need to notice, that as our input state only contains age as an input, so we need not to provide any other thing. We only need to provide age, and we should expect that output should only contain a single key, which is a info, because in our output state there is a single key info. So let's invoke this graph, and you can see now the node A, which is the input state, contains only age as a key, which is correct. Now node B, that is containing overall state, name and age, as we have passed only name and age from this node A, and node A has a edge from node A to node B. That's why this state is only having name and age. Now in the final output, that is output state, we are returning info, which is also correct, as output state can only contain info as a key. So now in this way, we can make sure that input and outputs are constrained to specific things as we required in our project. So now we have seen how we can define state, what is the use of state in LangGraph. We have seen how we can utilize different Pydantic and TypedDict type of states. We have also seen like how these multiple schemas can help in different use cases. Now in the next video, we will see how reducer functions can help to update these states. So thanks for making till the end of this video. Goodbye until the next time.